Yeah, no problem. Today I am using my laptop for
Oh,
recording purpose. Okay, so our topic of discussion, I have collected means I have pointed out these topics initially. Why we are doing this class? Basically, see, mm, in our syllabus, not in our syllabus, in India especially. Okay, I have
okay.
come across some syllabus from the states and other European countries. Okay, their
Mm-hmm.
pattern of syllabus is something different. Okay, but
Mm-hmm.
here in India, basically, although it is recorded, but still, I can say that something is not correct, not suitable. See, we have the data structure classes in the first semester. Na?
Yes.
There were lots of algorithms, especially there were algorithms. The subject deals with lots of algorithms. Okay, although it has
Correct.
an implementation part, but there was lots of algorithm. But the analysis of algorithm we are doing here in the second
After.
semester. Okay,
Correct.
so analysis of algorithm means you have to choose the algorithm, you have to design the algorithm in that way. Okay, so that should be learned fast. Okay, after that
Mm-hmm.
we will create the algorithms for every data structure and apply the data structure into the application. Anyway, no problem, we will learn in that way. We are habituated in that. So our aim means the subject tells you to choose a particular algorithm which is most suitable, which is efficient, which will perform for you the best. Okay, so to choose an algorithm among every other options. Okay, but how to choose it? To choose it, you need a analysis. Okay, so this is the purpose of this subject, means you are analyzing an algorithm and designing according to that of your analysis. Okay, so that is the basic need of the subject. Now when this subject will be taught by the classes, okay, in
Mm-hmm.
our regular classes, from the very first day I am assuring you that you will heard the term something called big omega. Okay, then the
Mm-hmm.
linear time, exponential time algorithm. Okay, what is the best case, what is the average case of this algorithm? Now where do you get this knowledge? Okay, so you
Mm-hmm.
will have no idea. So our aim
Correct.
for today's class is to give you the idea what all these things are. Okay, what is meant by complexity analysis, what is algorithm, and how to analyze and estimate the time complexity for a algorithm. Okay,
Mm-hmm.
if I can complete this thing, I do not know whether I can complete the whole thing today. Maybe one more class will be needed. Later we will do that thing. But I am just linking this today's class or this subject with two of your prior things. Say
Mm-hmm.
here you will find something called recursive. Okay, not
Mm-hmm.
recursive. See, this is recurrence. You find recurrence in mathematics, na?
Yes.
Last semester. Okay.
Mm.
Another thing you will find here, function. It is not the programming language function. It is the mathematical
Not a
function.
mathematical function.
Okay. So little bit of mathematics will be there. Let's see. So we will start. Okay. Now, first of
Okay.
all, let me ask you a question. Do you know what is an algorithm? Obviously, we all know. Na? Algorithm.
Yes.
What is algorithm?
Mm.
Algorithm is a
Step step by step procedure.
okay. It is a step by step.
Written in a normal language
It's a procedure. It's basically a procedure to express the logic, express
of a
the
program.
working principles of
Mm-hmm.
something. Okay. Algorithm does not mean that it is meant for the computer programming languages and computer applications. Okay, it is everywhere. Algorithm is a general term. It is a step-by-step process describing technique for any problem, how to get a solution. Okay, now for a particular problem you have many solutions. Now
Yes.
for a particular problem you may have many solutions.
Correct.
Among all those solutions you need to choose a particular one which is most suitable for you and for that period of time. On that particular time, what is most suitable for you, maybe it is not suitable in any other case. Suppose if I give you an example, suppose you want to reach to your office. Okay, you want to reach
Okay.
to your office. Okay, this is your house. From house you want to reach to your office. Now there are several options with you. You can
Correct.
take a cab, right? You can take a
Mm.
cab. You can take a public transport bus. Okay, you can take a mm,
Two
you
wheeler
have
or any
two wheeler.
one
You have a scooty
transportation.
or a bike. Okay, that you can
Mm.
also take. Even you can walk through your office. That is
Mm.
also a possibility. Okay, you can go to walk. Suppose you want to travel to your family or some friends to
Mm.
some other country, maybe say US. Okay,
Mm.
so that time you have the options of uh,
Flight.
flight. You may take a cruise. Okay, ship.
Mm.
Okay,
Yes.
even you may take a jet, means a
Mm.
rocket that is
Mm.
used to send
That's it.
um, astronauts to the space center. Okay, even that you may
Mm.
take. Okay, so these are the different options you have. Okay, in different place. Now see, uh, suppose if you want to go to your office, then will it be feasible to take a flight?
No.
You want to go to the US to your friend, will it be feasible to take a bus?
No.
Feasible. I am not saying that it is not. Is it possible? Yes, obviously these are all possible. Okay, you can take a rocket to reach to your office from your home to, because it is the fastest one. Okay, the rocket is the fastest
But
one.
it is not feasible.
It is not feasible. Okay,
Mm.
so every time which one is fastest will not give you a feasible solution, right? It is
Yes.
okay. Maybe your office is just next two buildings away from your home. Okay, so that time cab is also not be a suitable one to reach to your office,
Correct.
right? That time
Correct.
walking will be the suitable one. But walking is the slowest process of everything now.
Yes.
But still, to reach to your office, if the
It
office is
might
very much nearby to you, is the most
more
suitable one.
suitable.
The same way, while we are making a solution, making an algorithm, okay, sorry, not making an algorithm, while we are trying to solve a problem, we may develop many algorithms. But among those algorithms, some algorithms will be feasible, some algorithm will be based for some cases, and some algorithms are based for some other cases. So
Correct.
deciding the particular algorithm for a particular case is the
Mm.
output of this analysis of algorithm. Analysis of algorithm, right? So this is the aim of this subject, to analyze the algorithm and decide which algorithm is best feasible for your current problem, right? Is it okay?
Yes, it is fine.
Okay. So it was our first 2 points. What is an algorithm? We understand what is an algorithm. Next, the purpose of this paper and the connection to the data structure. So let me tell you that it has a direct connection to the data structure. Why? Can you tell me?
Developing with to
Developing a
choose the
particular
best.
solution Okay, while
Mm.
you are developing a particular solution, that time you will handle with lots of data, na? Obviously you
Yes.
will handle with lots of data.
Mm.
Now think what happen if all the data are scattered, not organized properly, then
Mm.
obviously your solution will not work efficiently, na?
Mm.
So you have to organize the data in such a way that while using the algorithm, while you are doing the algorithm, while your algorithm is actually working, so taking the data and working on the data, fetching the data, storing the data will not be a very much um, what factor of bother. Okay,
Yes.
so your data structure comes into the place. Okay, you
Mm.
select a suitable data structure for your suitable solution. Okay, so the
Yes.
communication of algorithm and data structure in such a way, we while we are developing an algorithm for a particular solution, for a particular problem, we also choose a suitable data structure. Now data structure means what? We already learned the stack,
Organizing the
array, queue, tree,
cues.
okay,
Mm.
graphs. So these are all the data structure which are which have their own algorithms which will be used in different algorithms. Okay, so
Yes.
data structure connection of the subject data structure with the algorithm is in that way. Okay, you have to think, you have to correlate with
Mm.
this thing. Anyway,
Mm.
the next part is your algorithm as a
Mm.
machine. You have to understand, or you have to think that algorithm is a machine. Now what is a machine? Machine is machine. If you define a machine, then you can obviously define it in that way. It is a device that will take some inputs, and after processing it will produce some outputs. That is the basic definition of a machine, right?
Mm.
Now
Correct.
machine should not always be a hardware, like your
Mm.
air condition AC. That is a machine. Your laptop is a machine. Your car is a machine. Everything is a machine. We identify what are the machines in our life. Okay, but in case of software, in case of computer science, a particular software is also a machine. You have to treat it as a machine. Okay, say for a
Yes.
particular algorithm, can you name any of the algorithm that we have learned in our last semester? Give me name of any algorithm.
Algorithms in data structures. Huh?
Yeah, in data structure. See, we have learned sorting algorithms now.
Sorting we learned.
Say we learned quick sort, maybe
Quick sort. Yes.
quick sort,
Then the bubble sort.
bubble sort, quick sort. Say
Mm.
this is an algorithm.
Mm.
Okay, so think it as a device. It is taking an unsorted list of elements. After
Array.
processing, it
Mm.
is producing the sorted list. Na?
Yes.
So it is a machine. Okay, so every algorithm you have to consider that algorithm as a machine. Okay,
Okay.
now when you consider an algorithm as a machine, think when you in your real life you went to uh, a shop to purchase a machine, suppose air condition. Okay, you want to purchase a AC for your home.
Yes.
Now what are the factors that you will consider before purchasing a particular AC machine for your home? So what are the factors that you will consider? Tell me.
What will be the time means temperature, up to what temperature it can cool, then how much power consumption it may take, then is it automatic or means how it is being controlled,
Okay,
then the size of
tell me the primary factors. Means you can obviously consider every other features. Okay, say it is bio, क्या means
mm,
today we have
yes,
something called bio. क्या कहते
bio,
हैं उसको?
yes,
मतलब I don't know
yes,
what is
eco,
eco. Okay, maybe
eco,
eco
mm.
to means power consumption will be less, maybe something like that. Bio का कुछ होता है
Even
मतलब there is something called
bio
bio
be
term.
yes it is because the natural air kind of thing
Okay,
they
okay,
wanted
maybe
to
maybe
connect with.
So you may
Uh,
consider those features also, but what are the basic? See, you are going to purchase an air condition AC. So what will be
mm,
your basic need? What are the basic needs, or what will be the basic feature that you will
temp
look into the
that what a temperature
temperature?
control, how it's
Okay,
called, how
okay,
it's maintained.
temperature. So how much temperature it can lower? Okay,
It can
so
cool into.
cool
Yes.
into. Okay, so say I am the shop owner and I am saying you that, madam, take this AC. I have an AC. Okay,
Mm,
so take it. It is a very cheaper. Okay, you
mm.
ask me first. Then what is the temperature
Make.
of it? How can it?
Yes. What
How
kind
far
of
can it cool?
brand it is.
So I am telling
And
you, I am
warranty.
assuring you. No, 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 not branded. It's not branded. I am assuring you that it will. Its performance as far as chilling is concerned is very, very much. Means if you on the means the AC,
Mm,
then at once within 2 minutes your room will be chilled out completely.
okay.
Okay. You ask me then what is the money? No? The next
Mm,
consideration. I am telling
yes.
you that it is only cost of 2000. Only 2000.
Mm,
Tell me, will you take that machine from me?
mm. No, we will be have to validate ki whether it is
Why not?
durable is there.
You are getting it by only 2000. Say I am giving you 1000 rupees discount again. So you are getting it by 1000 rupees. And you are getting an AC which will means which will make the atmosphere chilled within 1 minute guarantee. Will you not take it? Obviously, you
We
will take it. Okay, I can show you the demonstration. I told you
yes.
that
Okay.
you will give me money after 1 month.
Testing
Obviously, you
something.
will.
Okay, fine. Definitely we'll go for it.
Okay, next, yeah, you tell me. Okay, you just feed the AC in my room.
Mm,
By next day, I will not be there. Okay, but you went there,
mm,
and my family will be there. You will feed them. So
mm,
after next day, after reaching to your home, you see
mm,
that your room is almost filled up with the AC.
mm, mm.
Means I fit
Size.
a central AC, okay,
Mm.
which is almost as
Fill.
much as the size of your room. So
No,
the
of course
only
I will
space
not.
left may be a few square feet in your room.
Mm.
Okay,
No.
so I fit a big that you find that a central AC in the shopping
Machine.
mall or
Hmm.
big factories, something like that. I fitted you over there.
Mm.
So tell me, will you keep that AC?
No, 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 we will not be.
Obviously not.
Size obviously will be matters.
Exactly.
Size matters.
Size matters. So that is the factor, one factor. Okay. So not only the time, okay, but also we need to understand the size of a machine. Okay. So obviously,
Correct.
when we are buying a machine, when we are choosing a machine, we are considering that it will produce the output, or it will make the work very easy and in a very, very less time.
Mm.
So this is your time. This is your time consideration. And
Mm.
in case of algorithm, we say that this is time complexity. But also,
Mm.
you need to understand about the space requirement. Okay. And that is
Yes.
in algorithm is termed as something called space complexity. Okay. But in
Okay.
today's discussion, we will not consider the space complexity, and obviously in our syllabus space complexity is not very much. Okay, so
Mm-hmm.
everything will be dealt with time complexity, with time
Time
complexity. So we
complexity.
are
Mm.
considering the time complexity. So you have to consider a algorithm, your algorithm as a machine. Now while purchasing a machine, what are the consideration you took before purchasing a machine? That consideration will be taken in case of algorithm before choosing a suitable algorithm. Okay,
Algorithm. Okay.
so tell me, up to this, is it okay?
Yes, fine. It is.
Any question you have? Choice of an algo on the basis of performance. So we can summarize it as a performance. Okay, so performance
Mm.
is it is taking a less amount of time. Sorry, it is
Time,
taking a less amount of
space,
space as well as less
space
amount of
and
time.
time.
So these are the two basic factors of choosing
To
an
choose
algorithm
a
or choosing a
algorithm
machine. Okay.
machine.
Hmm.
Okay.
Space means what? You can you clarify a bit?
That's
What
what
is?
in case of means how much space it's going to occupy to fit that machine if we are considering it as a machine.
Yeah, in case of algorithm.
Hmm.
So what is the space complexity?
Space means how lengthy could be, how many steps we may use it to solve this
No, no,
solution
no,
or
no,
to
no.
arrive at a solution,
Space
or
complexity.
space or the memory of how much it may require to store that
Exactly.
to
The memory.
memory
Space means memory. How
memory
much RAM will be
it may
required to,
consume.
not the hard disk, not the hard drive
Yes,
memory,
yes, 100%. RAM only because it's
on
the
RAM
working
only,
part
because
means.
you are considering your algorithm while it is on, while it is
RAM
executing, while it is
executing.
on run, in run. No.
Yes,
So
yes,
while an algorithm is running, so it is occupying some space from the RAM, from the memory.
yes,
So space complexity tells you that how much RAM memory space will be occupied by your algorithm. Okay.
correct. Mm.
So generally we use the variables in the algorithm while implementing the algorithm as a program.
Algorithm.
We declare
Yes,
the variables, right? So those
yes,
variables accumulately they will take memory spaces from RAM.
yes.
So while writing a program, okay, you must
Mm.
consider that, see, generally we have a practice who are just freshers and not writing the programs for the means live purpose, means the client based
Yes.
application development purpose, who are not
Mm.
writing that kind of program. Generally they have a practice taking a variable randomly. Okay, we need
Correct.
something, take a variable, take five
Yes.
variable, take six variable, take an array, the big large size array, 100 elements array,
Mm.
500 elements array. Okay, so these
Yes.
will automatically increase the,
Increase the
so
space
your algorithm
occupied by RAM.
becomes space hungry.
Yes.
Okay, so minimize the space complexity is one primary aspect
Major
of
selecting an
analysis of
algorithm.
algorithm. Okay, selecting an
Mm-hmm.
algorithm. Although you may say that space is very much available in today's computers, or space is very means very easily available and
Mm.
cheaper. Okay, RAM obviously it is very cheaper. When I started, when I have my first computer in my hand, in you
Mm.
may say it is the year of 1998. Okay, that
Mm-hmm.
time I have just 1 MB of memory. Can you imagine? 1 MB.
Okay.
Yes, you are listening right. 1 MB of memory.
Yeah, for
Okay,
memory.
so after 6 months, I purchase another 1 MB of memory. So that
Mm-hmm.
2 MB of memory,
2 MB
I
RAM.
go with means I do not require need to upgrade my memory till year 2000. Okay, almost three
Oh.
years. Okay, I go
Mm-hmm.
with the 2 MB of memory, because that time those programs were not, obviously GUI was not so available at that
Yes,
time.
COI based.
Yeah.
Many of the programs were COI based.
So today's memory hungry applications, okay, for that memory hungry application, why they created those memory hungry applications? Because memory is very easily available. Okay,
Yes.
it's fine. Memory is easily available and it is cheaper. But your algorithm must consider that thing also, that while you are developing the algorithm, memory requirement, your the memory that you
Mm.
are using for your program is very much less, because think about while you are developing the mobile application. Okay,
Mm.
so till today mobile application are say while you are trying to download an apps from Play Store,
Plus to
obviously you look into the memory, na, how much memory the app will take
100,
place. If
100%.
it is over
Yes.
100 MB of memory, then okay, no, 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 I will not take that
Correct.
app. So this is space complexity for an algorithm. You have to think about the space also. Okay, coming to the concept of complexities. Now, let me tell you one more thing. Complexity. What is complexity? Complexity means, see, this is measurement. Okay, you have
Mm.
measurement. So this is also a term from software engineering. Okay,
Mm-hmm.
just a minute. Measurement. Acha, tell me, measurement, can't we measure something like that? Measurement, I can say that measurement are of two kinds, that is direct and
Indirect.
indirect. Can't I say? Direct measurement. Okay, if you measure your height, you will get an
Just a
exact
second,
value.
Saurashji. Just a second. Battery is low in my laptop. I'll just put it for charging 2 minutes.
Okay, okay, okay.
Mm.
So I can say that measurement can be a direct and indirect. Okay, suppose if you want to measure your weight, then you will get a
Mm.
definite and perfect value. So these type of measurement are
Mm.
can be treated as a direct measurement, right?
Direct measurement.
But suppose you are telling somebody that he is a good guy. Okay, then tell me what that person will understand
No, we
about.
cannot measure that
He
one.
cannot measure, means good means what kind of
Uh,
measurement it is. Okay, so obviously now suppose you are telling me that mm, uh, Srinivas is a good guy. Okay, now how
Correct.
can I identify a
Uh,
good? Do not have a specific definition, huh?
I
So
cannot measure it accurately.
yeah, obviously, so I will not have an exact measurement. Okay, so this is an indirect measurement. Why it is an indirect measurement? So if I tell you that sorry, I am not understanding,
Mm.
Srinivas is a good guy, please
Mm.
define. So now you are telling me that
Mm.
Srinivas is a good guy, as
Mm.
good guy, as good as good, like your Sikant.
Mm.
Okay, then I can identify, okay, I know Srikant. To me,
Mm.
Srikant is also a good guy. Okay, Srinivas
Mm.
is good guy like him.
Like him. Mm.
So this is an indirect way of measurement, right?
Okay.
So we need lots of measurement in our life. Okay, not
Mm.
only in life but also in everywhere, every task we need some kinds of measurement. Okay, here in
Mm.
also algorithm, while choosing an algorithm, we need a
Mm.
measurement. Okay, but by any means you cannot measure the time taken by an algorithm. By any means you cannot measure it. Although it is not, I cannot say that it is not possible. You,
Mm.
obviously, with the quantum clock system, it may be possible, but because a computer processor works in nanosecond, milliseconds, na? So we hardly have any clock to measure a perfect time for an algorithm. Although we can do in some other technology, but that cannot be used very frequently, very often for every application. We cannot use that kind of clock to measure the exact time in terms of seconds, hour, and minutes for our
Yes.
algorithm, right?
Correct.
Obviously, for space we can have a direct measurement,
Respect. Yes, we can have.
but for time we cannot have a direct measurement technique. Okay, so
Yes.
here we need to take indirect approach. That indirect
Mm.
approach will uh, give you an idea, okay, of
Mm.
what time the algorithm may take while executing. Now think, the purpose of having the time complex is, this is called time complexity. Okay, so
Okay.
time complexity is basically an indirect way of measuring the time,
Mm.
runtime, for a particular algorithm. Okay, it is okay, na?
Okay. Okay.
Okay, fine. Now see the why we need the time complexity, why we do not need the exact time. Obviously we do not need the exact time. We are not bothered about the exact time of an algorithm. Okay, why?
Yes.
Because
Based on the application user, how long?
no, actually we have to select a particular algorithm from several different options, several different algorithms. Okay, so while we are trying to solve a problem, we design, or we have four different algorithms. Okay, now
Okay.
among the four different algorithms, we have to choose one or two. Okay,
Mm.
so always we are trying to compare the time taken by the different four algorithms. Okay,
Yeah.
so now see here we
But
are actually
ultimately, our
comparing the
solution
time.
is. Mm.
That means while you are comparing the time, it is an indirect way of measuring. So assumption and approximation will come into play. So we do
Correct.
not need the exact amount of time taken by an algorithm to produce the output.
Mm.
Okay, so time complexity is an indirect way of measuring the time, running time.
Okay.
So up to this, okay, na?
Yes. Okay.
Okay. Now moving the next part, time complexity analysis. How? How to analyze an algorithm? Okay.
Mm.
We have two different types of algorithm. One is your non-recursive and another is your recursive. Recursive we will tell later. Today
Okay.
we will not cover recursive because time will not permit. So
Mm.
that is a separate day problem. Today we will discuss about non-recursive algorithm. Okay.
Okay.
So what do you mean by non-recursive algorithm? Means the algorithm where the recursive function call is not present. Okay.
Okay.
Okay. Now, whenever you are comparing or whenever you are measuring something which cannot be made direct, okay,
Mm.
maybe I can say that we have to take the help of the mathematics. Okay, mathematics is such a subject.
Mm-hmm.
See, whenever we are in trouble to
Mm.
describe something,
Mm.
okay, we look into the mathematics. We go to the
Okay.
mathematics and pray to him, okay, give me a solution, give me a way out. So mathematics is basically a key for
Mm.
every subject, for every science related items to get a solution. Okay,
Okay.
so here also, when you are mm, trying to get an idea of the running time of an algorithm,
Mm.
so mathematics will give us such a model. Okay, and that is in terms of function. We can say function, mathematical function. You
Function.
remember
Okay.
mathematical functions?
Yes. Yes.
Function. We had something called functions and relation in the last
Functions and
semester.
relations we were doing.
Okay, the inverse function, everything was there.
Recursion functions.
Hmm. Recursion was not function. Recursion function that you are telling about the programming language point of view. Anyway, see,
In that, for
func
recursion, it was repeated in two chapters. If
recursion.
in the beginning they had added with the function, and then
Okay,
separate
okay,
chapter was there.
okay, maybe. See, what we have to do. Suppose we have an algorithm. Okay, suppose we have an algorithm. Okay. Now this algorithm means what? These have some specific lines of code, right?
Yes.
These have some specific lines of code. Now these lines of code will be executed by the CPU processor, right?
Yes.
And it will take some time, amount of time. Say it is
Correct.
T. Just try to understand. Don't think that it is a very deep concept or a very complex concept of mathematics. Not like that. Okay.
Mm.
So algorithm is lines of code. So every lines of code will be executed by the processor. So it will take some time. Say t amount of time. Okay.
Yes.
Sorry. Now you can easily identify that this algorithm is running in machine, say M1. Say it is running in your machine. The
Yes.
same algorithm is running in a different machine, say M2.
Mm.
Same algorithm is running in a third machine M3. So can you tell me that for each of the machine it will take t time? Obviously
No,
not.
it may vary based on the machine.
It may vary, it must vary, because every machine, you may say that no, this M1, M2, M3 have same processor and same architecture and everything is same, but even though the time will not be the same. Okay,
Okay.
so for each environment the algorithm may take different time. Okay, but we will not consider this. What we will consider, we will consider that this algorithm is running on a universal machine. Universal machine means it is an ideal type of machine, hypothetical. Okay,
Mm.
say here we will consider that this algorithm will run on a universal machine. Okay, we are not considering that it will run on i3, it will
M
run on
specific,
i5, something not like
not
that.
specifically.
Okay, so we are considering that this algorithm will run on a universal machine.
Mm.
Acha, one more thing, that this is an instruction, this is another instruction, this is another instruction. So in a real time machine, real life machine, each instruction will take different amount of time. I
Correct.
repeat, in our real time machine, real life machine, each instruction will take different amount of time. So in that way, we can say that this first statement is taking t1 amount of time, this second statement is taking t2 amount of time, something like that. Okay,
Correct.
we will also not consider that thing. We will consider that in this universal machine, every line of code will be executed in a constant time, say t amount of time.
Okay.
Okay, t amount of time. Every statement is working in t amount of time. So you may ask me why we are assuming so much of things. Then what will be the advantage or of the algorithm or time complexity? Knowing the time complexity. Again, I am telling you, we are not going to find the exact amount of time, right?
Yes.
So this consideration will be taken for all
Approximation.
all algorithm. So we have currently we have three algorithms
Four.
in our hand, right?
Mm. Mm.
A1, A2, and A3.
Mm.
So this consideration will be applied to all of the algorithms. Okay. So
Mm.
if this consideration is same for all algorithms, and after that you are getting something, say this algorithm has a time, say I am saying TC1,
Mm.
this has a time complexity TC2, this
Mm.
has a time complexity TC3. What I
Three.
am trying to say, that we are applying these rules, these conditions on every algorithm. Na?
Yes.
So after applying the same rule on every algorithm, we are determining that this A1 algorithm has a time complexity of TC1, this has a time complexity of TC2, and this
TC2.
is a TC3. And
TC3.
I am telling you, after that we find that TC2 is less than TC3 and less than TC1,
One.
then we will
Mm.
select it. Na?
Correct.
Somehow if we can decide that TC2 is less than TC3 and much
Mm.
less than TC1,
TC1.
then obviously TC2 is the best.
Best algorithm.
In that way we will compare the algorithms. Okay,
Mhm.
so there is no harm by taking this assumption. Okay,
Mm.
it is okay.
Yes.
Okay, fine. Now you have to understand how can we derive that thing, this TC1, TC2, and TC3.
Mm-hmm.
That we will derive by using the function. Okay,
Function.
now I can tell you that every algorithm, so this is an algorithm. Okay,
Mm.
this algorithm can be represented as a mathematical function. Every algorithm can be represented as a mathematical function. Now, if you remember mathematical function, say
Sorry.
you can say y is equal to fx. That is a mathematical function, right?
Yes.
Then we can say that y is a means y is a function on x. You remember the
Mm.
term on x.
Yes, yes.
So maybe if I define it y, so if I define the function as a square, then you can say y is equal to x square. Now what that means? Whatever value of the x, if I square it, we will get the value of y.
Why?
So y is such that, so y is dependent on x. So
Yes.
whatever value of x, if we square it, we will get the value of y.
You will get the
So
y.
this is the function. Okay, this is the definition of the function.
Mm.
So when I am saying that every algorithm can be represented as a mathematical function, then
Mm.
obviously question arise, function on what? है ना?
Yes.
So while I am telling that every algorithm can be represented as a mathematical function, then the next question will automatically come, function on what?
Based on number of steps, is it? I don't know. I'm right or not.
No, no, partly you are
Mm.
right. Okay, so I can write every algo can be represented as a mathematical
Function.
function on size of input. So this is the term,
Okay.
on
Okay.
size of input.
Size of n. So it is obviously once again indirectly connecting with number of variables you use. Am I right? Or I
Number
don't
of
know.
variables, no? Size of input. I am giving you the example. Don't worry.
Okay.
Okay. Just
Okay.
what you need to do, you have to remember this thing. Okay.
Okay.
So you cannot easily remember this thing until and unless you practice it. Practice means what? Practice means you have to listen this recordings. Okay. And obviously, if you want to read, then I can send you some PDF or PPTs. Okay,
Mm-hmm.
or even some written notes by me, so
Mm.
that you have to read and you have to imagine. Just this is an analytical
Visualizing.
subject, na? So you have to imagine, you have to visualize the thing.
Visualize things.
Okay, so you can take example from your daily life. Okay, take any example and try to analyze it. So try to identify what is the time complexity of that thing. Okay, so uh, try to derive the mathematical function out of it. So in this way you can practice it. It is not a programming language that you write a program and see the output. It's not like that.
Correct.
So
Mm.
it is an analytical paper. So you have to imagine, you have to visualize the
Visualize the
thing, and you
things.
have to apply in theoretical concepts. Okay. So every algorithm can be represented as a mathematical function on the size of input. Suppose,
Size of n.
suppose to explain this thing, I am taking this example. Suppose you have an array, okay,
Mm.
and your array,
Mm.
I am not taking this thing. Suppose your array is of some elements, say 5, 7, 2. Okay. Now you are trying to search value from this array. So the
Mm.
size is 3 only. Now,
3. Mm.
now you have another array which have values something like that 3, 5, 9, 2, 7, 7, 2, 1, something like that. So you have some more number of elements.
Yes.
Okay.
9.
Clearly, if you have a searching algorithm,
Mm.
search algorithm,
Mm.
okay, if you input this, if you feed this array here and you are getting the result, you also feed this array here and you are getting the result, you can clearly identify that this will take less time.
Less and less time compared to the other one.
Okay, so I can definitely say that T1 will be less than
Less
T2
than T2.
in most cases. Okay,
Yes.
most cases. Why I am saying most cases?
There are few exceptions.
It is not always true.
Hmm.
Most cases. Why I am saying most cases? Suppose I am searching, say, what is it? It is 2. I am making it as a 3. Okay.
Okay. Five,
See,
seven, three.
I am searching 3. Okay.
Hmm.
Now see, while I am searching 3, to
Hmm.
get the result,
I
it
got
have to move to 3
move to
comparison. Na?
three steps. Here it is
But
only
here
two
it will
steps.
take only 2 steps.
Yes.
So during that time, okay,
Hmm.
so it will take less amount of time than this
And
one. So most case,
most of the
or in the
cases
average case, this T2 is much
is
greater, will be
much
greater
greater
T2.
than or
But
taking more time compared
yes,
to T1.
when I am telling this T2 is this T2 will be greater than T1, then on the basis of what I am telling this thing? On the basis of the size.
Mm.
If the size is your S1 and the size of this array is S2, see, this is true. Why? Because S1 is less than S2. Okay.
Mm.
So your algorithm can be, so see, the output producing by this algorithm.
Mm.
So we are considering the time complexity of this algorithm. Na?
Yes.
So the time complexity of this algorithm, we can easily say that it depends. It depends on the size of the input.
Size of the array input.
So it is the function of n, while n is the size of the input.
Size of the input.
So we are considering the time complexity can be treated as a function of size of input.
In.
Okay. Generally, we can say that uh, I am not using the term time complexity directly here. We can say that this algorithm can be represented as a mathematical function of on size of input.
Based on
We
input.
generally use it the symbol fn.
Mm.
So fn will be our algorithm where n is the size of input.
Size of input.
N is input size. Okay. Up to this, okay, na?
Yes.
Now we have something, some different types of algorithm, and we will convert each of them to its corresponding fn. Okay. So
Okay.
we will consider different algorithms and we will convert each of the algorithm to its corresponding mathematical representation or mathematical function. Okay, let's start. I am
Okay.
writing an algorithm. Say algo 1.
Mm.
Here I am taking input A. See, I am not giving the step 1, step 2, all those
We
things.
can,
Okay.
no problem. We can
Input B,
understand.
C is equal to A plus B and print C. That's all. So this is a simple algorithm, right?
Correct.
Are you following the thing?
Yes, yes, I'm
Okay,
getting.
okay, okay. So this is a simple algorithm, right? So
Mm.
what is the purpose of this algorithm? This will
Set two numbers, find the sum of it,
input the
and
two
display
numbers
it.
and find the sum of the two.
Mm.
Okay. Now consider that. This is one statement. How much time it will take? Tell me. We have considered that this
T1
will work for an
seconds.
universal machine,
Yes.
and the time
Time
taken
one.
by any statement we will consider it as a t. Okay.
T.
So how much
T1.
time this statement will take to
T1
execute?
second. T1.
T, not T1, I am taking
Mm.
T. So
Okay.
this statement will also be executed in T
T
unit
time.
of time, right?
Mm. This
This
also will
will
be T
also
unit
be
of time.
executed in T unit of time because we see these are the two input statement and this is a summation statement. But we consider that every statement, irrespective of the
Every
type of the statement,
type of the
in
statement.
real life, obviously these two different statement will take different amount of time.
Correct.
But we have to go on a hypothetical
And
basis, okay? So there will be no harm by taking this assumption. So here we are assuming that every statement will be executed
taking
in the
the
same amount
amount
of
of
time.
time.
So t is
Mm.
constant, okay? So
Okay.
this will also be executed in t amount of time, and
Mm.
return statement, obviously we are taking again the t amount of time.
Yes.
So a total amount of
Five.
time is what?
Five.
1, 2, 3, 4, 5.
Mm.
So it will be executed in 5t
Five
time,
t
right?
times. Mm.
So we can define that our fn is equal to 5t.
Five t.
Now I am writing this thing here. Fn, just follow this thing, okay? 5t. Now tell me here, 5 is a constant,
Mm.
obviously.
Mm.
What is t? T is also constant, na?
So constant.
Because we are executing, we are designing the algorithm for the universal machine.
Yes.
So can't we say that fn is equal to a constant c,
We
while
can.
c is a constant? We're taking
Yes.
that c is a constant, okay?
Mm.
Constant, okay? So
Mm.
fn, our function will be like that, is equal to c,
C.
where c is a constant. This
Constant.
is the function where
Mm-hmm.
c
Is
is
constant.
constant. C is constant. This is a constant function. See, on the right hand side of this equal to, there is no n. So it
Mm.
is not that the function is not depending, or you may say the time is not depending on the number of input. Okay.
Yes.
Whatever be the input, it will take always the constant amount of time.
Mm.
Now, what type of algorithm this is? This is such an algorithm where you are not finding any loop, right? You are
Yes.
not finding
It's a
any recursive function call.
recursive function call.
So this is a simple algo, simple. You may
Mm.
have some switch cases, you may have some if and else, okay, but there is no loop, there is no nested loop, okay, there is no function call, there is no means recursive function calls. So these type of algorithm are called constant algorithm, and constant time will be taken
Mm.
by the processor or by the machine, okay. Again, I am explaining that wherever you run this program, or suppose you are running this program in a machine M1,
Mm.
okay. So hypothetically, how many times, as many times you run this algorithm in M1, it will take same amount of time. Suppose
Yes,
Tm.
because we have taken it as a constant. We have defined based on the
That's
constant
why we are
time
saying that this
factor.
algorithm is a constant time algorithm.
Mm.
Suppose you run this algorithm on a machine M2, okay.
Mm.
So, and you are running 100 times this algorithm on machine M2. Each time it will take T of M2.
Correct.
Okay, that's why we are saying that this algorithm is a constant time algorithm. And that constant time algorithm is represented by this mathematical function. Okay,
Yes.
later we will derive that the complexity, time complexity, okay, usually with something you already heard the term BIGO. That's why I am using the term here. But in our next class, we will explain it and we will derive the BIGO notation from here. So the time complexity of this type of algorithm is denoted by BIGO of 1. Okay. So if someone tell you that what will be the time complexity of this one, okay, you will say this is a constant time and the time is this one. So this is the time complexity Tc of constant time function or constant time algorithm BIGO of 1. We say it. Tell me up to this, okay?
Yes. This week only win. I need to know. I did
Yeah, yeah.
not get the idea
We
clear.
usually
As you
tell
said.
that
Mm.
this type of algorithm will have a time BIGO of 1. We will
Okay.
derive these BIGO notations, okay, later.
Okay,
But I
fine.
am just mentioning, just for keeping the notes here, that the
Hmm.
time complexity of this
Hmm.
type of function is represented by the notation
B.
big O of 1. Okay.
How do we spell it?
Sorry.
How do we spell that term?
Big
Big
O. OH.
O. Big O. Okay, okay.
Next, we have another type of algorithm. Suppose, say, algo 2. Say, input in I is equal to 1, S is equal to, say, maybe 0, and we are using a loop while I less than equal to n. I hope this simple algorithm, oh, you will have no problem na, writing this
Yes, no
simple
problem.
algorithm.
Yes, no
Sorry.
problem.
Say I have S is equal to S plus I.
Plus I.
Okay.
I plus
Then
plus.
there will be I plus plus. Yes, rightly guess. Then you are going to print
Print S.
S. Okay. So this is an algorithm which consider a single loop, right?
Yes.
No nested loop. You can have
No less.
multiple loops, consecutive loops, means one loop after this loop. You can have that thing too. So this is
Yes.
another type of algorithm which is different from the previous one. Okay.
Yes.
Now
Correct.
see, we also consider here for this algorithm the time.
Each statement time will be t
Now tell me,
times.
there are some important
Here in the
factors.
loop, this time will be
This will
multiplied
be
based
t,
on n.
right?
Uh,
This statement will be 3.
this is
This
also t.
statement will also be t.
Here it
See, you are
changes.
considering that this is also a statement, na? So
Yes.
obviously this
This
will take some time. So how much time it
yes.
will take?
N number of times till n.
Sure.
I guess like that, but I don't know. But
Okay,
because
okay.
this statement will, because it has to repeat these other two statements. So one, two statements will be repeating for n number of times.
Okay. See, I can say that this will be a sum of time, because t is the time taken by one comparison. Na?
One
So how
comparison.
many comparison will be there?
N
There
number
will
of
be I
comparison.
is equal to 1 to n plus 1.
Oh, ho, ho, ho. This is
Because
state
up to n it
formula
will
looks
run.
very simple now.
Up to n it will run. But to the base condition, means when it will
Base
terminate.
condition also required. Yes, yes. I is
So that
equal
is
to
also a
1 up
checking.
to
Na?
n plus 1. Hmm.
Okay, fine, no problem. So you can always omit one or two comparison or one or two statement, because all these things are hypothetical basis. Okay,
Hmm.
so approximation. But still,
Hmm.
oh, why will you not do that thing? Okay, next tell me what will be the time taken by this statement.
Uh, this will also be taken for I to n times only, no?
Yeah, this time you are right. So I can say that this will be a
Uh,
sum of
uh,
time I
time
is
n
equal to
equal to
1 to n,
n,
and this will also be the
same
same,
thing.
because this is the loop body and this is loop
Yes.
head. Loop
A
head will
loop head.
always execute one more time than the body. Na?
Body. Yes.
Okay, fine. So this will be your t.
T time.
So ultimately this is your n plus 1 t. Na?
Hmm.
N plus 1 t. This will be your nt,
NT. This is
and this
also
will also be
NT.
your nt. So if you sum it, then what you will get?
One, two, three.
Just a minute. This subject is very interesting to me, you know.
Even for me, I'm getting it. And maths has become simpler. Math formulas are looking simpler here.
Okay,
I
maths
used
is
to.
okay. Obviously, maths is always interesting to me because it is mysterious, and you can.
No, the I'm saying like it became this for complex formulas. What I used to feel in math
Hmm,
is looking simpler here after using this.
hmm. Why this
It
subject is
was looking
interesting to me?
so
Because
complex.
it has means the analysis means you are free to analyze your thoughts. Okay,
Mm.
so whatever there is means whatever the subject where you can analyze the thing that attracts me much more than anything else.
Mm.
So let's move. Let's calculate it. So Fn will be here. See, here is your 1,
One,
2,
two,
3, and
three,
40.
4, 40
So 40
plus
plus
n plus 1t,
n plus 1t means you have 2 nt na
2nt,
plus
plus
n plus 1
1t.
t. Okay.
Mm.
Okay. I don't know whether my voice is recorded or not, you know, because I didn't have the time to check it before
No,
starting
no,
the classes.
last class we checked. Nah, I think the same procedure if you're doing it would have been there.
क्या पता? Okay. So how much it will be? Say you can take 2 nt and here again an nt. So you'll be your 3 nt na?
Mm.
3 nt plus you have 40 and here
And
you will have 1t. So you will have
1t,
5t, right?
5t. Correct.
So here, see, I am writing this thing in this way. You will agree that 3t dot n plus 5t.
Plus
Can't I
5t.
write that? Obviously.
Yes. Then
Now I am
8t.
taking that this is your a n
Mm.
plus b.
Okay,
Why?
this
I
we
am considering
arrived to
a is equal to
is equal to
3t
3t,
and b is equal to 5t, right?
5t.
And
Mm.
these are both constants,
Mm.
right?
Yes.
So
This we did know in math last time. This kind of problems
yeah,
means with the different variable we were doing it.
yeah.
We proved this kind of sums.
So here our consideration is different because
No, no, no.
we
I was just
okay, okay, huh?
derivation. It
See,
was clicking for
this
me.
type of algorithm can be represented as a mathematical function of this type. Okay,
Mm.
this type of algorithm means what I mean by this type of algorithm, the algorithm which contains no
Contains loop.
nested loop or even
Only the
nested loop,
simple loop.
a simple loop. Okay, you may have nested loop. Okay, but in
Mm.
practice if the inner loop is not running
Mm.
more than once, then you can say
Mm.
okay, it is also a algorithm of
Simple
this
loop.
type, algorithm type.
Mm.
Okay, so you may have consecutive loops, means one loop ends here, another loop starts here. So all these type of algorithms where you will have a loop like this, you will have no recursive function that can be treated as a function of function like this,
Function of a
and you
n
can say
plus
this
t.
is a linear function, na?
Okay.
Linear
Mm.
function on n. Why it is called
Okay.
linear function? Because see, n have no power, no exponent, and nothing else. So this is a
Nothing. It.
linear function.
Yes.
Okay,
Correct.
polynomial linear function you can say. So this is a polynomial a n plus b. Okay, here you have n to the power 0, b n to the power 0. Here you have a n to the power 1. So you can consider it as a polynomial of n. So this is a function which will represent all the algorithms of this type. It is okay, na?
Yes, it is fine. It's gettable.
Okay. So obviously you have one thing that is a constant function and you have
Function.
a linear
A
function.
linear function.
Okay. Now when we will find the time complexity of linear function, we
Mm.
represent it as big O of n. The time
Mm.
taken, time complexity, time
Mm.
taken by the linear function,
Mm.
we say that the time complexity of a linear function means the algorithm like this will have big O of n.
Big of n.
Now, why big O of n? Where are those A and B gone? We will discuss everything in detail. No problem.
Okay.
So once you
Okay.
have the clear idea of these things, okay,
Mm.
so you will take that analysis of algorithm subject is interesting, and it's very much comfortable to get those concepts. Okay, later.
Yes.
So we will discuss also how this
In
big O
some
comes from.
MCQs was there, no, this one. Big
Lots of
O.
MCQs can be found in this subject. Okay.
Like last time also we had, no, like something you had even shared with for so many.
Yeah. Before data structure exam, I shared.
Yes, yes, you had shared so many values it was there.
That's why I told that we have to learn these things
Data,
before.
this was data before learning data structure.
Okay, and you remember that in the revision class, I also asked them that
Yes.
why you are giving those time complexities, why
If,
when you did not take the
did
classes.
not teach the algorithm
Okay,
analysis analysis of algorithm.
so उन्होंने तो कहा था मतलब कि they replied in such a way
Syllabus
that
is
analysis
planned.
मतलब time complexity will be there, must be there. Yes. Uh, anyway, I should not say anything more. Anyway, the next type of algorithm quickly, we are running out of time. Algorithm 3, right?
Okay. Mm.
So how far we can go today?
Today, what
Algo
is that?
3.
We can go till I think that's what 10 till 10, 10, 5 like that. We can the other type of algorithm can we finish it?
Okay, no problem.
Okay. Because I think this week a little time constraint is means I'm not completely okay to attend the classes
Hmm.
because already we missed last classes. That's the
Hmm.
reason
Last week we did not.
I'm taking the this thing.
Okay, so let's
Lit,
do it. Algo 3.
okay, fine.
Okay,
Hmm.
so we are taking here input n, right? And we are taking s equal to say 1 and I
Hmm.
is equal to 1 while I less than equal to n. Inside it, j is equal to 1 and while j less than equal to n. Inside, this is inner loop. You identify
Nested loop. Yes, I
nested
got
loop.
it. Nested loops.
So
I know them.
here s is equal to I, say maybe into j. Okay,
J. Mm.
and we are incrementing j here by j plus plus.
Mm. I should be incremented.
I
Outer
also will be
the
incremented and
print
outer loop ends,
printing.
right?
Yes.
Fine. So this completes our algorithm of this type. Okay.
Mm.
So as we did for the last two, we
Mm.
will also find the
Try to
total time.
total
You can
time.
say the running time, okay, for this
Mm.
algorithm.
Mm.
So what will be the time?
First,
This will be
first is
t.
constant T.
This will
T.
also be t. This
Another
will
one
be
is
your
also
t.
written.
What will be the
This will
time of
become.
this? This
This
will
will
be
be
your n
sum of
plus 1 t. I
n
am
plus
not
one
writing the
T.
summation sign. Okay.
Okay,
So
n
to
plus
make this
one
thing,
T.
so n plus 1
Mm.
t. So this will be
Mm.
your nt.
N T.
What
This
will be
is
the?
n plus n n plus one.
See, this
Means
is
j plus one.
the here I am giving you the summation sign. Say this will be
J
your
is
j
equal
is
to
equal to 1 to n plus 1.
1
Na?
to n plus 1.
But since this is a inner loop, so it
Mm.
will also have a sum of this time for I is equal
N
to 1 to.
1 n
So ultimately it will give you n into n
n
plus
plus 1
1 t,
t.
right?
Yes.
Then this one will be
Will
your,
be NT.
not nt, n into nt.
Oh, correct. Sorry, it is again nested loop.
Yeah. So this will be your
Mm.
n into
N into
nt,
NT.
means n square t,
Mm.
right?
This also be N square T.
This
Yes,
also
correct.
be n square t,
Mm.
and this will be your
This
nt.
is B NT. This will be T.
This will be your t. So
One,
what
two,
will be the
three.
total time?
E. Uh,
Yeah, you do not need to calculate all those terms, but you
mm.
can easily guess that it will have something n
Mm.
square na.
Yes.
So we will write the thing in this way. You can make a sum of all those things, but
Yes. N square.
ultimately you will get
You will get
something like
F
that.
of
F of
N
n
is
is
equal
equal to something a n square
square
plus
plus
bn
Bn
and plus c, where
plus
what is abc? ABC are all
A
constants.
constants. Yes.
A maybe say 60, B maybe say
Yes.
80, something like that,
Mm.
na?
Correct. All constant
You
only.
are getting it, na?
Yes. Yes. I'm getting it.
So A, B, C all are constant. So
Mm.
the functions, the algorithm of this type. Now,
Mm.
what I mean by this type? Again, algorithm which contains the nested loop. Okay,
Mm.
nested loop of two level. This is one level, this is two level. Okay,
Mm.
you will you can represent the algorithm as a quadratic function of on n, quadratic
Mm.
function on n, a n square
Mm.
plus b n
Bn plus C.
plus c, where a, b, c all are constants, right?
Mm. Mm.
So function algorithm of this type can be represented by the quadratic function of n. Okay,
Mm.
this is also a
Mm.
polynomial. Okay, but this is not
Correct.
linear function. Here, this is a
Mm.
linear function,
Linear function.
but it is a quadratic
This is
function.
quadratic function.
But again, it is a polynomial. Okay,
Mm.
so the time complexity we use to apply for polynomials, okay,
Mm.
is the we take the highest term of the
Mm.
polynomial. So we represent big
Big,
O of n
big
square.
U.
So whatever be the algorithm which contains this type of nested loop up to two levels,
Mm.
the time complexity of that algorithm can be represented at big O of n square.
N
Now
square.
again I am telling how I get big O of n square from this polynomial that I will describe in the next class. Okay.
Okay.
Tell me, up to this, okay?
Yes, I got it.
Okay. Now I can continue this thing. Say algorithm 4 will be
Mm.
something like that, while, and again third level of while.
I can. I
Okay.
under
Then what
got
will be the complexity of that?
Com-
Sorry, what will be the function,
f
mathematical
of n
function
will be
represented?
f
So you
of
can
n is equal to
f of n is equal to क्या हो सकते हैं? What will be that
uh,
thing?
a n cube
Yeah, very good. And you are
plus
getting the
bn
thing.
square bn
Bn
square
square plus
plus
cn
cn plus d
plus d, something like that. So again, the
okay.
complexity for this you will
Will
get
be big O a n cube.
cube. Okay.
Mm.
Why we are
Okay.
choosing n cube? We will
On the
then explain.
higher okay,
Yeah,
on a
obviously.
higher
We will
polynomial.
tell everything in the next class for asymptotic notation, obviously.
Mm.
Okay. So in this way, you can
Mm.
identify, you can represent every algorithm, every type of algorithm. Okay.
Time complexity function with terms to
Not time complexity. You are representing the algorithm as a mathematical function. Our
algorithm.
today's
Sorry, we
class
corrected.
is
Yes, yes,
just
we
to
corrected.
consider the represent. We are representing
Representation
an algorithm
algorithm
to its
in
respective mathematical function.
function.
Okay.
Mm.
Later we will
Okay.
use that function to find the time complexity. That is, these are the complexities. Okay, these are the complexities that we will have to derive. We will derive it. Okay, but here Fn is the mathematical representation of a particular algorithm.
Algorithm.
Okay,
Mm.
so these are all the types of algorithm we have.
Mm.
Now here something we done this polynomial. Okay,
Mm.
polynomial representation. Now if your algorithm is
Mm.
a recursive algorithm,
Mm.
then we will use something called recurrence. And I
Mm.
tell you that we will use the term means recurrence later next day.
Okay.
Okay,
Mm.
so completely separately I will discuss about the recurrence and recursive algorithm.
Okay.
Okay,
Mm.
today we will show you, so let me save it, a graph. Next day we will again show this graph to you.
Okay.
Why it is not copying? Okay, fine. Okay, see,
Mm.
these are the different classes. These are the different classes of times.
Mm.
So we can plot something like that.
Mm.
So this is
Mm.
the number of inputs. Okay, n
Mm.
x-axis. This will be the time taken. Okay,
Mm.
by the algorithm. So
Mm.
if we can plot the time taken by an algorithm
Mm.
for the value of n. Okay, suppose n
Mm.
is 100, then what will be the time of the algorithm?
Algorithm.
So in that way you can plot the different
Mm.
values of big O. Okay,
Mm.
so these are the available values. General, say n,
Log n.
sorry, not
Mm.
this one, not this one, log
Log
n,
n.
log n,
L-
n,
Lin.
in log n. This will be your
Log
in
n.
log n. It is
Mm.
rightly in
Log n. I got it.
log n. Then there will
Mm.
be your n square.
N
See
square
here.
n.
For this reason,
Mm.
I am taking this picture today. Okay. Otherwise, I have
Okay.
to show this picture after the growth rate concept.
Mm.
Okay. See
Concept.
here, n square, n cube. You may have,
Up to 2 to. Mm.
yeah, you may have n to
Mm.
the power 4. In that way, n to
4.
the power x you can have.
Mm.
After that, you
Mm.
have these things. These are
2n
called
and
exponential functions. Okay.
mm-hmm.
These are called exponential functions. These are the polynomials.
Polynomial.
These are the polynomials. Okay.
Mm.
Within that polynomial, this is your linear function.
Mm.
Okay. And constant is not showing here. This is constant. Okay.
Mm.
Constant, obviously, that will not be plotted here now because
Mm.
there is no t. T is 0.
Note. Yeah.
Okay. It's
Mm.
a constant, not 0. A constant. Constant will be something like that as a parallel line,
Mm.
parallel to the x-axis. This is constant.
Yes.
So whatever value of the n, it does not matter. It will always take the same
Uh,
amount of time.
Same amount of
Constant.
time.
So this is constant. So see here, look at the curve. Okay.
Mm.
You just look at the curve. You can identify that
Mm.
you know na how to identify the curve. You have the idea of curve na representing that
Which is
we also had this concept in our mathematics class last semester, say
mm.
histogram and those all things. You remember the term histogram and curve
Histogram. I
fitting,
remember. Mm.
those things, pie chart, okay, those
Mm.
chart and everything. Here this is a curve. See here, here n will increase na.
Mm.
Suppose here the value of n is 100.
Mm.
Let us assume here the value of n is 100. Okay,
Mm.
100. Okay. Now, if you draw a line here, straight line, straight line. So you draw a line, straight line here. Okay.
Mm.
So to get the value of t,
Mm.
you have to put this line something like that. Okay.
Yes.
We are having a line here, and we are having a line, another line here.
Mm.
Okay. See here. This is the time
Mm.
taken by this
Whereby,
algorithm 2 to the power n. Okay.
yes,
And this is the time taken by
taken
n
by
cube algorithm,
n,
and this is the time
linear,
taken by means
linear.
the n square algorithm.
Yes.
This is n square line, this is
Huh.
n cube line. So the value of
Huh.
corresponding t is what? Say suppose this is t of n cube
Huh.
and this is t of n square. Okay. So obviously you can identify that t of n cube is greater than t of n square, because t
Yes,
of
I
n cube
can.
is above t of n square.
Above the T. Yes, yes. This
So
comparison I know.
yeah. So from
Mm.
this plot you can identify n square. Which one is better? Tell me, which one is better?
N2 is better.
N2, no, n square.
So,
n,
sorry, n
n square
square.
is better. Obviously it
Yes.
will, because it is giving the less amount of time
Less amount of time.
than n cube.
Hmm.
Okay. So by comparing these things on a
Hmm.
particular value of n, okay,
Hmm.
particular value of n, say n value is 100. So if you compare the thing, see, you will find that log n takes this amount of time, this amount of
Yes.
time. Okay.
Hmm.
N will take this amount of time, means this amount of time. Okay. In that way you have to
Correct.
read this graph. Okay.
Yes, yes. Hmm.
So
I
this is
got it.
the,
What you mean to say? Hmm.
yeah, this is the concept of plotting the graph and identifying which algorithm takes the less amount of time and which is better. And this is see, this is for a particular value of n. Okay.
Hmm.
If you look closely to the graph, see here there are some intersection. Na?
Hmm. Intersection is there.
I am just showing it, means I have to create, say I am just creating in this way. Say this is taking at least two straight lines. Okay. Say suppose
Hmm.
you identify n square is uh, say you will find something here, say n log n is better than n square. Na?
Yes.
You identify from the graph n
Yes, I can
log
identify.
n is less
Hmm.
than n square. You identify the thing. See how
Yes.
the comparison takes place. So if you plot n square, then your n square may be, maybe something like that. Okay.
Hmm.
Suppose for a particular algorithm, for a particular problem, your n square, while you are plotting the value of t
Hmm.
with respect to value of n, okay, you
Hmm.
are getting n square in
In this,
this
yes.
graph of n square. Okay.
Hmm.
Now I am plotting the n
Log
log n,
n.
n log n.
N log n. Okay.
So this is your n log n. Now what is the significance of this graph? Can you identify?
Means it just took lesser amount of time initially, but gradually it is.
See, n square is taking less amount of time
Hmm.
here. Okay, initially
Yes.
for initial values of n.
Initial value. Hmm.
But after this point, See, there is a huge gap between these two. So
Yes,
for the
yes, it
long
is.
run, in log n will give
Will
you the
take
best time.
best time. Hmm.
So it is efficient. Okay.
Hmm.
So we are bothered about the higher values of n, not the lower values of n. We are not bothered about this part. We are bothered about the higher values of n.
Higher.
When
Hmm.
the input size is really large,
Increase.
millions,
Yes.
millions and
Hmm.
millions of input size,
Hmm.
that time how your algorithm
This.
will behave.
Hmm.
Okay, that is our consideration.
Hmm.
Okay, and that is something called growth rate. We will start our next class from that point. Okay,
Okay.
so how to consider those algorithms. See, we have completed up to this. Okay, so next
Yes.
day we will start from here. Growth rate.
Hmm.
Okay,
Growth rate.
means how to derive those big O notations. Okay,
Hmm.
and you obviously know, you must know that not only big O notations, we have something called big omega. Okay, this is your big O,
Hmm.
big omega, and big theta or theta
Hmm.
notations. Those notations are called asymptotic notations. Now, asymptotes
Hmm.
is a mathematical part, means in a mathematics,
Hmm.
higher mathematics, you will have something called asymptotes. Asymptotes are
Hmm.
some kinds of graph, sorry, curve,
Hmm.
some
Hmm.
kind of graph, lines, curve, you can say curve, which are very closely related but never meet. Those are called
Hmm.
asymptotes. Means these
Okay.
two are called asymptotes, asymptotic
Hmm.
curve, if
Hmm.
they never meet, but they are trying to meet.
Hmm.
Means they are approaching to meet somewhere, but will never meet in future. This type of
Okay.
curves are called asymptotes in mathematics.
Hmm.
Okay,
Hmm.
and asymptotic analysis or asymptotic notations will give you the limits. Means
Okay.
uh, if you can correspond it, if you can link it with our algorithm analysis, so it will tell you the limit, the highest limit of time it will take, the lowest limit of time, the best time you
Okay.
can
Okay.
take. So something related to
Different parameter we can analyze.
different amount of time, means the limits of time, that this
Limits of
algorithm
time.
will take at most this time. At
Hmm.
means if it is going to work slow, then at most
Hmm.
this time it will take. Okay,
Hmm.
so for that purpose we will use asymptotic analysis. Okay,
Hmm.
so best case, average case and worst case will also be there. So we will discuss
Hmm.
everything in the next class. So
Okay.
should we stop today?
Yeah, we can stop for
You,
today.
yeah.
Most of the new terms also actually we I got it.
These are completely new to
Yes, very
you
new.
all,
I think
especially for the freshers.
one more time if I go through this class,
Yeah,
then
obviously
I
you
have
should.
got it around 90% I've got it. But
Mhm.
still, I have to just listen to it, all this new concept, then it will
Yeah.
100%
That's
register.
why I am stopping here, because this
Huh.
type of converting an algorithm to a mathematical function is not, it's it's not what I say. Uh, it is completely new. It should be completely new to
Yes,
you people. So I'm
yes,
stopping
yes.
here. Next day we will start from here and we will move forward to make the big O notations. Okay.
Okay, okay.
Okay, then thank you
But
and good night.
थैंक यू
और आपके
तो
लैपटॉप का
आपका
क्या खबर है? आई एम
शेड्यूल है क्या
स्टॉपिंग द रिकॉर्डिंग. ओके.
या हाँ स्टॉप कीजिए
ओके, रिकॉर्डिंग.